Today we're going to cover brake proportioning valves and tuning of your brake system. Your braking system takes the driver pedal force and converts it to a force at the wheels. Typically this is about 20 times more output force at the wheel, somewhere between 5 and 2,000 pounds of force for the driver pedal effort, which is typically 100 to 200 pounds of force. You need to make sure that the system has this mechanical advantage, or else the driver's strength may not be enough to actually stop the car or bring the wheels into slip. This braking force ratio will have two components to it, a hydraulic component and a mechanical component. Mechanically, the pedal itself has a ratio where the driver's force on the pedal is increased when it's applied to the master cylinder. The rotor itself also provides some mechanical advantage because the rotor has a diameter where its force is applied at some distance from the center of the wheel. And the actual size of the wheel can influence this as well. If you have a really big wheel, it will take more force at the actual brakes to get the same ratio at the wheel. The hydraulic component of your overall brake ratio comes from the difference in the area of the bore of your master cylinder compared to your caliper. And to calculate this, you can look online and find the master cylinder bore size for your car or any aftermarket master cylinder, and you can either measure with calipers or look up the bore size of your particular caliper. If your caliper has multiple pistons, you're going to want to add up the area of all of the pistons on one side of the caliper. For example, with this fixed style caliper, you look at the area of just one of the pistons and you treat it the same as if it was a floating or sliding style caliper where it only has a piston on one side. If your car uses a power brake booster, the booster itself will also contribute to your overall pedal force ratio, because the booster typically will put out about 1.5 times the input force as an output force due to the power addition of the vacuum of the engine. If you have a power brake system and you're removing the power brakes, you need to consider the fact that your brake system will now have a reduction in output force for the same driver input force. This difference isn't very big because you're only looking at one element going from a 1-to-1 force ratio to a 1.1-to-1 force ratio. But if your car already is difficult to stop and has high pedal effort, you may need to resize your master cylinder to a smaller master cylinder, which will increase the force at the wheel for the same pedal force. If you're changing out the calipers on your car and you need to determine what master cylinder you need to run, you can simply look at the master cylinder to brake caliper area ratio that your car had from the factory and maintain that ratio with your new calipers by choosing a master cylinder that is approximately the same overall ratio. If this was a 2 or 3-to-1 ratio, maintaining that 2 to 3-to-1 ratio in area will maintain the same wheel output force for the same pedal force. You will hear drivers often complain about or talk about a car having a balanced brake system or not being balanced. And what they mean is, for a balanced brake system, you should be able to lock up all 4 wheels at roughly the same time, or lock up the front wheels just slightly before the rear wheels lock up. This is important because if you lock up one axle ahead of the other, you're reducing your overall braking potential and increasing your stopping distance. In order for you to have a balanced setup, you need to have the proper brake bias, which is the difference between braking force front and rear. Typically, you will see much higher front braking forces, and this is due to the fact that a lot of cars have more nose weight, but also as the car is decelerating, you're increasing the load in the front tires, and thus to have balanced brakes, you need to have an increase in braking force in the front tires. This causes the brake bias that you need to change depending on how fast you're decelerating. If your car was 50-50 weight distribution and you were decelerating very slow at a fraction of a G, a balanced brake setup would have almost the same brake force front and rear. For the same car that has 50-50 weight distribution, if you're braking at 1G, you'll need substantially more front brake force than you do rear force. Because of this, the brake bias that you need is constantly changing, and you need to tune the brake bias for your particular car and grip level. Your brake bias is determined by both mechanical and hydraulic elements in your car. Mechanically, the size of your rotors front to rear can determine the brake bias. You also get this if you have a difference in wheel size front to rear, or if you have a split master cylinder setup and you have a bias bar, the pedal force can be applied differently to either master cylinder depending upon where the bias bar is adjusted. Hydraulically, you can change your bias through either master cylinder bore size, if you have a split master cylinder setup, meaning that one master cylinder is bigger than the other, either front or rear. If you have a staggered bore master cylinder, which is generally rare, but in that situation, the actual bore size of the front and rear pistons is different. You can also change it through a prop valve, which will change the braking pressure applied after and before the valve. And in newer cars, some cars actually have ABS systems that control the braking line pressure and can change the brake pressure on one end of the car through the dump and reapply valve to change the brake bias dynamically depending upon how fast the car is decelerating. If you run an aftermarket prop valve, there are a couple of different types of prop valves available in the market. The cheapest one is going to be an orifice type, where turning the adjuster simply changes the area of the orifice or restriction. These don't actually change the final brake proportioning pressure. They really introduce a lag, and if you hold the brake line pressure high for a long enough period of time, the pressure will actually equalize and the prop valve will go back to doing nothing. Another prop valve design has a spring that you change the preload on, and this changes the line pressure only after you reach a certain level of pressure. This is sometimes combined with a piston that actually changes the pressure on either side of the piston and creates a change in output pressure that's ratiometrically different than input pressure. This change in pressure ratio is typically 1.2, 1.3, 1.5 to 1, and will occur at any point in time where you have exceeded this preload on your adjuster. What this means is that changing your knob adjustment on this type of prop valve will not change the bias front to rear. It changes the location or the pressure in the brake system at which you will cross over from 1 to 1, or the bias determined by the piston, which is 1.2 to 1.5 to 1. If you have access to a set of pressure gauges for a brake system, you can install a gauge in the front and rear of your car and play with your prop valve settings and determine what your actual change in brake pressure is front to rear, or your pressure bias. This can help you dial in the changes on your prop valves and see what they're really doing. And if you have a prop valve where you can change out the size of the piston as well as the preload, you can play with different curves. Now, you will notice in prop valve pressure curves that there is both a knee point, or a point where you exceed the preload on your adjuster, where the biasing is 1 to 1 before the knee point and some different ratio afterwards. And after the knee point, the slope, or the final pressure ratio, is going to be determined by the bore size in this prop valve. The brake bias you need in your car depends on how fast you decelerate. We talked about this earlier, and if you decelerate faster, you need more front bias. If you decelerate slower, ideally you need more rear bias. This isn't a linear relationship, and because of that, you don't end up with a perfect fit at all deceleration rates when you just have a single pressure ratio. Using the knee point from the preload in your prop valve, as well as the pressure ratio change from the piston in it, can give you a rough approximation of what this curve is, but it ends up only being really accurate within a narrow range of deceleration rate. So you're going to want to test this at approximately the acceleration rate you're going to see on track. This means that setting your prop valve in the pits when you're only going 10-20 miles an hour might not actually work on track, and typically people will end up with too much rear bias if they are trying to set their prop valve at a really slow deceleration rate. So to make these changes, you need to do them on track and do them gradually, starting with lots of bias to the front and slowly increasing the rear bias. You need to make sure you're only taking readings and making adjustments while the car is decelerating at a high rate, and I would concentrate most on your heavy braking zones, and especially as a new team, avoid the temptation to use the brake bias as a tool to fix some other handling issue with the car. If you need to change your brake bias front to rear and you don't want to use a prop valve, you can also use a brake bias adjuster and a split master cylinder setup. These are different than a prop valve. When you change your brake bias with a split master cylinder brake balance bar setup, you're changing the ratio at all pedal output pressures. There's no knee point if you do this. For optimal results, a combination of balance bar and prop valve can actually help out and do a better job of fitting the ideal brake bias curve for your car. Also, aftermarket prop valves that allow you to change the pressure biasing are generally really expensive, and a bias bar can be a cheaper alternative when combined with a less expensive prop valve to best fitting your ideal brake bias curve. If you need to make really large changes to your brake bias, another thing to consider is the limitations in how much adjustment a prop valve or a bias bar has. If you're having huge problems with rear wheel lockup, like you have in a lot of front wheel drive cars, you're going to have to decide if it's large enough that it will require a component change, perhaps a change in rear caliper piston size, or a change in master cylinder bore size to better fix a problem. We talked about it earlier, but most of your aftermarket prop valves are going to have a fairly small bias in them, 1.1 to maybe 1.5 to 1, and your bias bar may have physical limitations of about the same 1.5 to 1 overall bias between the front and rear circuit. If you're grossly out of balance and you need to make a gross large change, it's probably going to be from one of your major hydraulic components like master cylinder bore size or caliper bore size. One of the issues teams commonly run into is inadvertent balance changes or changes to the car that require a brake bias change. Some of the things that can cause a requirement to change your brake balance or your brake bias could be a change in compound on one end of the car or the other for your tires, a change to a different brake pad compound. Different tracks will have different grip levels, which will change your maximum deceleration rate, which, as we talked about earlier, changes your required brake bias. All these can be factors, and most of the time you can absorb it with a factory system if you have a very heavily front biased brake bias system. But you may end up requiring a prop valve, or it may be a good idea to simply incorporate a prop valve so that you can handle these changes at the track if they pop up. If you're having trouble sizing your brake system or you have questions, feel free to reach out to Willwood representatives at willwood.com. They offer solutions all the way from your pedal to master cylinders, hydraulic parts, prop valves, calipers, and even rotors. That concludes our section on proportioning valves and brake system tuning. Make sure you click the subscribe button, post any questions or comments you have, and we'll see you next time at Race Tech.